Hi everyone. I just wanted to take a quick moment and give you two examples of how to find the area of a figure on the lattice when the figure is not just one uh, nice rectangle or not a triangle that you can use the area formula for easily because you might not have a way to find the height. So in the top image you have a triangle. It's not a right triangle. So there's no way on the paper that I can measure the height and get an exact value. So one strategy that you might use is to build a rectangle around the triangle. I'm just going to draw a rectangle around the triangle so that it hits each of the vertices of that triangle. So I'm going to draw that rectangle here in red. So what I'm going to do is begin with the area of that red rectangle, and then I'm going to subtract the two right triangles that are not part of the original triangle. So that means whatever area I have left over will be the area of the triangle that I had started with. So I'm measuring the length of the rectangle. So the top length of this rectangle is 3. Remember, I'm counting the space between the dots and not the dots themselves. The other dimension of this rectangle, 1, 2, 3, 4. So the area of the rectangle is 3 times 4, which is 12. So from there, I'm going to remove the area of the triangles that are not part of the figure. So I'll do that here. I'm going to switch to black so it's easier to maybe see. So for the first triangle that I see on the left-hand side here, this one length is 1 and the other length here is also 4. So I'm using the area formula of a triangle. So for the area of that triangle, remember, area is base times height divided by 2. So the area of that triangle would be 1 times 4 divided by 2. Excuse my camera shake a little bit. I'm going to slide this over. So for that triangle, I would have 1 times 4 divided by 2. 1 times 4 is 4, and 4 divided by 2 is 2. So the area of this triangle right here would be 2. And the area of the triangle that I have on the right-hand side, I'll fit this down here. So this triangle, the length that we have on top here is 2, and the length that we see in this direction is also 4. So the area of that triangle would be equal to 2 times 4 divided by 2. 2 times 4 is 8, divided by 2 is 4. So the area of that triangle is 4. So I'm going to write the area in here. So the area here is 4. Area here is 2. Remember before, the total area of the rectangle was 12. Just off my camera view here. So the area of that rectangle is 12. So I'll go ahead and subtract the total area of 12 and then the area of the triangle on the left here, which is 2, and then the area of the triangle on the right, which is 4. So I have 12 minus 2 is 10. 10 minus 4 is 6. So that means that the area of the original triangle that I was trying to find would be 6 units squared. In this next example, I have a figure that is not a triangle or a rectangle. It's actually a composite of both of them. So in this case, I could split the figure up into two figures that I could easily find the area of. So if I split the figure up here, there might be more than one way you can split it up. But if I split it up there, I have a right triangle on top and a square on the bottom. So I can find the area of each of those individually and then add them together. So for the right triangle, I have a height here of 3 and a base of 2. So the area of that right triangle would be 3 times 2 divided by 2. which would be 6 divided by 2, or 3 units squared. This is a square at the bottom. We have 2 on each side. The area of that square would be 2 times 2, or 4. So then the total area of the entire figure, which is what I had wanted, would be the sum of 3 plus 4, which is 7, and that's units squared. So in that case, I'm breaking the figure up into 2 different units, finding the area of each, and then adding those areas together.